So we have section 4.8, solving problems with trigonometry. This will not be the only time that we do word problems with trig. When we come back from the holiday break, when we do all the graphing stuff, there will be more word problems, and these will be ones that are much easier once you have the ability to graph some trig. So today's stuff doesn't require you to be able to graph. Draw triangles maybe, but not graph. It's only 3 questions. The base of a buoy is 1,240 feet away from the bottom of a lighthouse. If the lighthouse is 130 feet tall, find the angle of depression in degrees. And I switched these 2 words. It should have said from the top of the lighthouse to the base of the buoy. So, because it is an angle of depression, so we're just going to do this and perform the old switcheroo. Because if you were looking from the buoy up to the lighthouse, that'd be an angle of elevation, right? Sorry, so I'm looking for the angle of depression. Basically, that's at the top of the lighthouse. So I'm going to draw a picture. Let's see. Picture not drawn to scale, obviously. But here's our ground, or water, or something. I don't know. Here's our buoy. I'll put a B there for buoy. And we'll have a lighthouse and an imaginary hypotenuse of a triangle. So, just like the angle of elevation, and just like all angles that we've been working with so far in our quadrantals, the angle of depression is measured from the horizontal. So this is not the angle of depression. The angle of depression would be modeled from, or measured from, there. So this is the theta that we're hunting for. That is an angle of depression. Wait, what?
Can you say that again?
Yeah, the angle of depression is always measured from the horizontal. So this is the angle that we're looking for. Not in here. However, some basic geometry. Do you remember what those arrows mean? Parallel. So what else do we know? Yeah, these are alternate interior angles. So now we have an angle inside our triangle that we can utilize. We know that the lighthouse is 130 feet tall, and we know that the buoy is 1,240 feet away. I will caution you, make sure that all the units are the same, okay? This one happens to be feet and feet. It's not always like that. Just be on the lookout for it. Make sure one's not in feet and the other's in inches, or one's in feet and one's in miles, or one's in minutes and one's in seconds, things like that. Just be looking for it, okay? All right, so we're just trying to solve for theta. Look at our triangle. If you were standing right here at theta, you know this side, which is opposite from you, and you know this side, which is adjacent. So what's a really good trig ratio here? Tangent. So we're going to say tangent of theta is the opposite side over the adjacent. Now the directions say to do this in degrees, and that's because it's a real-world question. Most real-world questions are done in degrees. So you just need to make sure that your calculator is in degree mode before you do any calculating. But I'm trying to find out what theta is, so how would I isolate theta here? Yeah, tangent inverse. You see, I need tangent to go away. I need to be able to cancel tangent. And you see how I drew this triangle? It would be in quadrant 1, wouldn't it? I mean, this is an acute angle. Since I'm in quadrant 1, since this is an acute angle, tangent and tangent inverse will cancel each other out instantly. So I just take the tangent inverse of both sides. That should be enough room to write that side, and there we go. So the tangent inverse of tangent of theta equals the tangent inverse of 130 over 1240. And these guys right here, they cancel out, leaving us a theta, which is what we were trying to do. Tangent inverse of this weird fraction. Bring in Dr. T.I. Ta-da! Okay, I am in degree mode, which you can see right there at the top of the calculator. It says I'm in degree mode. So we're just going to do tangent inverse. And 130 divided by 1240. Close your parentheses, be a good mathematician. Enter. Pow! It says to round to the nearest tenth. So that 5.98 will actually round to 6 because the 8 bumps the 9 up to a 10. So that is roughly 6 degrees. Well, think about it. Yeah, it's a small angle, but think about it. It's really far away. Yeah, picture not drawn to scale. Yeah. Now, it's really far away, though, so you don't have to look up very high. Now, the closer you get to this lighthouse, obviously, the higher you'd have to look up, right? Yes, what's up? Second tangent. So if you look at the tangent key and sine and cosine also, the right above them in blue is their inverse functions. Yeah. If you're trying to get your answer from the previous problem, answer is also in blue right here at the negative sign. So if you wanted to do, hey, that answer divided by 7, you could do second answer. Say you wanted to do sine of that answer. Here, let's see what it was. Okay, see right now it's not on. Check it out. Or it wasn't on. Look, I'm gonna hit second answer and hit equals. And it gave me back my answer. So if I want to know sine of that angle, I would just press sine and then do second answer. So yeah, second answer is our friend. Also, if you have this version of the calculator, you can just press up. Jokes. There it is. And it has all the stuff that I've typed in it today. Pretty easy, right? What do you guys say, light work? That one wasn't hard, was it? Okay. Well, let's see if I can take it up a notch for you. Unless you have any questions for me, I'd be more than happy to answer them. Okay, I'm not doing my job. Nobody's scared yet. Alrighty. From the top of a 100-foot wall, a man observes a car moving toward this wall. Okay, so we've got some dude sitting on a wall and sees a car driving towards the wall. If the angle of depression of the car changes from 22 degrees to 46 degrees, so yeah, it's going to change to 46 degrees as it gets closer because, you know, it's closer, so you had to look further down. We want to know, how far did that car travel? So when that angle changed from 22 to 46, how far did the car travel? I'm going to need a picture. It won't be drawn to scale, though. So here we have what was supposed to be a straight line. Let's try again. So here we have, wow, that's not much better. You know what? It's good enough. We're good. It's good enough. Here's our wall, and here is our imaginary hypotenuse. Cool. So dude's sitting on top of a 100-foot wall. I said Humpty Dumpty in first period. I didn't want to say it now because I didn't want to make it sound like I was saying the exact same joke. Well, you said it, I didn't. It was Brady. No, just so first period knows it. It wasn't me. Actually, McKinley Wimbish, she's in my first period, and she hit me with a mind bomb. What is Humpty Dumpty? What is he? Oh, really? Does it say that anywhere in the rhyme, that he's an egg? Yes. Have you seen he was a cannon. Yes, but what came first, the rhyme or the video? The rhyme came first. The point is... Wait, how does the rhyme go? I'm not doing that. It's a good try. It's a good try. She tried to get me. I'm not stupid. Okay. Shh. Look, see, this is what happens. Again, the rhyme came first. I don't know. I'm going to be doing some math now. Okay. This 22 degrees was an angle of depression, it says. So that 22 degrees would have been up here. But just like with the last question, alternate interior angles are congruent. So I also have a 22 degrees here. Now, I don't know this distance. So I'm going to call it x sub 1. Just go with me here. Now, same dude, may or may not be Humpty Dumpty, is still sitting on this wall. Still on the wall. Still 100 feet tall. Now, the angle of depression is 46 degrees. So again, alternate interior angles congruent. I can throw 46 degrees right there. This new distance, which will be shorter because the car is closer to us, is x2. I just need to know how far this car drove. Well, the answer is going to be the difference between those two x values. There we go. So what we need to do is solve for both x's and then subtract. Okay. So from this 22, my opposite side is 100 and my adjacent side is x1. So I could use tangent again, but here's my beef. I'd be trying to solve for the denominator, which is actually kind of more work than I want to do. So how do I make this x my numerator? Now, someone that understands a little bit of reciprocal stuff would say cotangent. But what I ask you is, how are you going to pull that off on here? The answer would still be 1 over. So now I'm dealing with all kinds of ugly fractions. Now I'm looking to solve for the numerator of the denominator of another fraction. Yuck. Please, someone, tell me a way that I could ensure that this x is my numerator and the 100 is my denominator without using cotangent.
Use secant.
I'm sorry?
Use secant.
Secant would require me to know the radius. Yes, I would need to know the radius, but unfortunately, I don't know anything about it. And you know what? Someone in the first period said the exact same thing. Use secant, and don't worry, nobody in the first period got it. I'm just curious to see. All right, what you got for me, dude? No, inverse won't do it yet. That's okay. Nobody in the first period got it either. You ready? A very simple geometry trick. Here we go. Remember, those angles are complementary. Now I can use tangent from 68 degrees, and x1 will be in the numerator. I know, right? Thinking smarter, not harder. Don't worry. Nobody in first period got it either. So tangent of 68 degrees equals my opposite side, which is now x1, over my adjacent, which is 100. So to get x1 by itself, all we have to do is multiply both sides by 100, and we have solved for x1. x1 equals 100 tangent of 68 degrees. I don't feel like drawing the parentheses, being lazy right now. And we're going to do the exact same thing to solve for x2. No, we are not going to round yet. I don't want you rounding until the very, very end, okay? So tangent of 44 degrees is opposite x2 over adjacent 100, and then just like the last one, multiply both sides by 100. So you want to know how far these things traveled? You just do x1 minus x2. Because x1 is going to be the longer side. You know, the car was farther away. It clearly said it was driving towards us. And as long as you're using a graphing calculator to calculate this will be very, very easy to do. So our distance is x1 minus x2, which is 100 tangent 68 degrees. No, you can't cancel the 100s. You could factor them out, but you're working too hard. We can't cancel because they're being multiplied to our tangents. Can't see the screen. Trying to squeeze it all in there. There we go. That looks like 10 degrees, kind of. 100 tangent of 68 degrees, close your parentheses, otherwise it'll be wrong, minus 100 tangent of 44 degrees, close your parentheses because you're a good mathematician, and hit equals. Woo! 150 and change feet. Now, this question did not tell us exactly how much to round to, so you just want to do 2 decimals? Okay. That car traveled about 150.94 feet. On the test, it's very specific about how to round. But you should not be rounding until the bitter end, especially because I'm allowing you to use the graphing calculator. There was no reason to round anything along the way. And here's the danger. If you round early, say you rounded that number, and then you rounded that number, and then you subtract, it's kind of like you're rounding a rounded number. You want to be really careful about that. I'd rather type it all in exactly as it's supposed to be and let the calculator handle it for me, and I'll just round at the bitter end. Cool? Yes, Ms. Brown? Fantastic.
Mr. McCutcheon,
yeah.
how'd you get 44? Again?
Because these two have to add up to 90.
Okay, so you just
I just did
like,
90 minus
subtracted
46.
90? Okay.
Or you could also say that these two have to add up to 90 because I made a 90-degree angle out of them. But it's the same idea.
Okay.
They're complementary. And we flip it over to the last question, and you might be thinking like, yo, math class was easy today. Yeah, that's because you haven't seen this question yet. Yeah, I figured make it something fun since the question is not. A large helium-filled penguin. You know what? They need to be careful with this helium. Did you know there is a global shortage of helium? Yeah, but do you know why there's a global shortage of helium?
The atmosphere is less dense and it goes right through.
Yeah, that, but also because we can't make it. So once it's gone, it's gone.
Macy's Parade is one of the biggest uses of helium.
Gosh darn Macy's Parade. Anyway, and we can't use hydrogen because those things go boom. A large helium-filled penguin is moored at the beginning of a parade route. That means it's tethered down, awaiting the start of the parade. Two cables, which are these hypotenuses, I'm not sure how to say that word. These cables are the hypotenuses of the triangles. They are attached to the underside of the penguin, and they make angles of 48 degrees and 40 degrees with the ground. So that puts these angles down here, 40 degrees and 48 degrees. How did I know to put them in that order? Well, just imagine you were standing on the ground looking up at the penguin. Wouldn't you have to look up at a steeper angle if you got closer to the penguin? So that's how we knew that the 48 went here. It says that they're in the same plane as a perpendicular line from the penguin to the ground. I don't know, maybe this penguin's got a laser poking out of its butt. I'm not sure. The point is we've got a perpendicular line here. It says if the cables are attached to the ground 10 feet from each other, so from here to here is 10 feet, how high off the ground is the penguin? And I'm going to call this distance a y distance. It almost seems like there's not enough information to solve this question. Oh, but there is. And it doesn't involve that trick that I did a second ago with finding the other angles. Could I find more angles? I sure could. But I require more side information. You see, in the last question, I knew two of the sides of the triangle. Well, I knew one of them and was trying to find the other one. Imagine what you have here is a smaller triangle inside a bigger triangle. I do not know a secondary side of either one of those triangles, do I? Ah, Lauren, you have an idea for me? You know, I wish it worked that way. It's a decent idea. She was suggesting that maybe if we move in 8-degree increments, we'll guarantee 10 feet. Unfortunately, it doesn't scale linearly because these things, if you remember, their graphs are curved. It was a good idea, though. Yeah. What do you think? Yeah, we could. We could put a 42 there, but it needs another side, doesn't it?
Oh, wait.
What?
What,
Worst case scenario is you're wrong. No, I'm serious. That's not a big deal.
Does it have to do with the two triangles sharing a side?
Well, yeah, that has something to do with it.
It does.
Yeah.
So it's the same length. Different.
What about if I called this length from here to here x? So now on this triangle, the 48, it does have a y and an x, correct? Doesn't the triangle that has the 40, it has a y, and now this side is not 10x, it's x plus 10. Like I said, worst case scenario is you're wrong. So now I can set up tangent for both of these angles. Tangent of 48 degrees is y over x, opposite over adjacent. And tangent of 40 degrees is y over This is the adjacent side, x plus 10. So how could this possibly benefit me? Well, maybe it's because I have two variables and two equations. So it's a system of equations. And substitution's a great way to do it. You see, because I could easily solve both of these for y. All I have to do is multiply by the denominator. So for this one, I'll multiply by x on both sides. And this one, I'll multiply by x plus 10. And now they both say y equals. I know that y equals x times the tangent of 48 degrees. And they also know that y equals x plus 10 times the tangent of 40 degrees. And since they both equal y, that means they equal each other. So since I'm down to one variable, clearly I'm going to be solving for x here. The only way I can solve for x is if I can get all the x's to one side. So I'm going to need to distribute this tangent to 40 degrees. No, we don't want to round. Just keep writing tangent to 40 degrees. Same thing for this tangent to 48 degrees. So I have an x tangent of 40 degrees when I distribute it to the x, and I have a 10 tangent of 40 degrees as well. Pow, there it is. And again, we're trying to solve for x. So I need all the x's on one side. So we're going to subtract x tangent of 40 from both sides. Wouldn't it be great if this was x tangent of 8 or just tangent of 8? Yeah, it's not. I was being sincere. It would be great. At first period, thought I was being sarcastic. They're like, oh, that's how it is, right? And I was like, no, you can't do that. So it is going to be, I know, why not is a good question. X tangent 48 degrees minus x tangent of 40 degrees equals 10 tangent of 40 degrees. We're trying to solve for x, folks. All this for a penguin, yep. Trey, what'd you say? Factor it out. X is a GCF on that left side. You could factor it out.
Let me pull out my measuring tape.
Don't you know we do this kind of stuff so we don't need measuring tape?
Yeah, but
So we can flex our brains.
we have measuring tape.
And we can make other people feel dumb. They're standing there with a measuring tape, and we're over here with paper and pencil like bosses.
Oh yeah, yeah. When I'm telling y'all are still writing numbers, and I'm like, it was a great measuring tape.
I got a really good story for you about that.
Measuring tape.
Well, it's similar to that. Let me go ahead and finish this question. We're going to divide both sides by this number. This number's not pretty. This is the best way to write it. So we're going to divide both sides by tangent of 48 degrees minus tangent of 40 degrees. And all of this is gone now. So we get x equals, running out of space here, x equals this wild fraction, x tangent 40 degrees. This is honestly the reason why I'm allowing you to use a graphing calculator. Basically because of this one question. Oh, that's right. There is one of these on your test. Wouldn't you rather know than it be a surprise? Well. Okay, now, you don't have a graphing calculator?
No.
Then you need to be a master of parentheses. Actually, it's not that bad, okay? Which scientific do you have?
What?
Which scientific do you have? Is it the good one or the bad one?
I think it's a good one.
Is it battery operated?
It's this one.
Oh, the bad one. Oh, man. Okay, so first I'm going to demonstrate how to do it on an actual calculator, and then I'm going to demonstrate how to do it on a potato, just for her, okay? All right, so let's... Okay. So, this is a stacked fraction, yeah? If you have this version of the calculator, you can use stacked fractions. If you have an older version of this calculator, it probably can't do stacked fractions. So I'm going to do it without the stacked fraction, just in case, because I know everybody can do that. So do 10 First of all, make sure you're in degree mode. 10 tangent to 40. Close your parentheses, otherwise it thinks you're still typing inside the argument of the tangent. I'm going to hit divide by. I now need to tell the calculator that there's going to be multiple objects in the denominator. Now it knows. Dude, my phone is going off in my pocket. What the flip is happening right now? 13 things just came across. Yeah, alpha variable is a shortcut for it, but not everybody's calculators can do that. So that setup, that parentheses that I just opened right there, just told my calculator I'm gonna have a couple different things down there. So I'm gonna hit tangent to 48. You have to close the 48 parentheses, otherwise it still thinks you're typing inside of that tangent. And then minus tangent of the 40. You have to close up the 40 and then close up the denominator. Then you hit enter. And you get that x is about 30.9-ish feet.
No, I could have done that with my tape.
Oh yeah? And you'd have been wrong because that's not what the question asked you to find.
Ah,
I just used an extra set of parentheses right here. Shh, we're not done yet. We're not done yet. Here. Here.
oh, you just put the whole thing in front.
Yeah, I just put the whole denominator in parentheses. You see, the reason why we're not done is because what I just found was x.
It wants the height, doesn't
It wants the y value. Good. Everybody who's got their panties in a twist can calm down because look, it's right here. So y equals the x value you just found times the tangent of 48 degrees. But hold on, don't type that please, because it's not 30.9, it's 30.9 and change. But since that number's already on the screen, I'm just gonna hit times, and you see now it's not even rounding. Now it's taking all of that crap, and which is hiding right there in A and S, and I'm gonna multiply it by tangent of 48 degrees. And I'm gonna close the parentheses because I'm a good mathematician. Enter. There we go. So that penguin is about 34 point, does it tell me how to round? It does not. Let's call it 30.32 feet above the ground. You might have been able to do that with the tape measure. Now, whoops. Now it's potato time. And it is possible. Yes, you have a question for me? Hold on. Okay, yes? It was asking for this. Oh, I circled it. It wanted to know how high above the ground is the penguin. So we were solving for y. When we solved for x, we found this number here, but we were supposed to find that, so I just used this. You mean use this one? Yeah, you could have done that. Yeah, it's the exact same answer. Okay, doke, smoke. Here we go. This is how you do it on the TI-30XA. Are you ready? Okay. First of all, that, oh my gosh, it has multiple things on the bottom, does it not? Yeah. Do you know how to use the parentheses command on this thing? You do? Yeah, but are you good at it? So here's how I would do it. If you're not very good at it, I would say, and am I in degree mode? I am. I would do 48 tangent minus 40 tangent, and then you have to hit equals. Good? Divided by 40 tangent equals divided by 10. What I did was I divided by both of the objects on the top, right? Because they're multiplied, so I did division. So what I just do? I just did this thing upside down, didn't I? So then just hit the 1 over x button. Boom, there's your answer. Mm-hmm. No, what I did was once I typed this into the calculator, I divided by tangent of 40, and I divided by 10 as 2 different steps.
But like one after the other without saying enter?
I hit enter in between them. You got to hit enter in between. So there you go. And that is how what is this called? Finding height above the ground of a penguin. Indirect measurements using trigonometry. Woot!